So in today's video, we'll learn a new technique for differentiation that will become very, very valuable as we go forward throughout the year. First two, let's say we had y equals 2x in parentheses to the 4th and y equals x cubed in parentheses to the 15th. Currently, how we would have to attack this is we would have to rewrite y here as 2 to the 4th, x to the 4th, which means that y would be equal to 16x to the 4th. Then we could take the derivative of that. 4 times 16 would give us 64, and we'd have x to the 3rd. So we can work with that. Over on the right, we would have to rewrite y as x to the 45th. And then y prime would become 45x to the 44th. Now, we might not be able to do that in all cases. Let's look at these two cases. If we have a binomial raised to the 7th, it could be done, but it would be a huge pain to write that out all the way. The bottom one we could rewrite as x squared plus 1 to the 1/2, but there's nothing really we could do with it to make it into something that we know how to take the derivative of currently. So therefore, we need a new method. If we went directly from each of these, our derivative here would be y prime is equal to 4 times 2x cubed times 2. And over here, y prime would be equal to 15 times x cubed to the 14th times 3x squared. So, this is our new rule. Let's see if you can look at it and figure out where this is coming from in our original problem. The 4 is the 4 that was our exponent just coming out front. Notice the 2x stays the same, and we're now raised to the 3rd. The times 2 is coming from the derivative of the inside part, the 2x. What this method is called is it's called the chain rule. You use it when you have a composition of functions, meaning when you have a function inside of another function. Our power rule and all of our derivative rules are when we're working with a plain old x. We will use the chain rule when there's something other than a plain old x where we usually have an x. In this case, we would normally see like a plain old x to the 4th. That would be our base function. But because we have 2x raised to the 4th, we have to treat this with the chain rule. So again, the 4 came out front. The inside stays the same, and our exponent went down 1. And then we multiplied by the derivative of the inside. Now, just like all of our derivatives, you could leave it just like this if you want, or if you wanted to neaten it up, you could write it as 8 times 2x cubed. And just to show you that it would be the same thing, this would be 8 times 2 cubed x cubed, which is 8 times 8x cubed, which is 64x cubed. So notice it was, in fact, the same. Now looking at our right-hand one, we had the 15 come out front. We kept the inside the same. Our exponent went down to 14. And our derivative of the inside now was 3x squared. So we did our normal derivative rule with power rule, but leaving the inside function as is. So we left x cubed as is, and then we just multiplied by the derivative of x cubed afterwards and got 3x squared there. To show you that this is exactly the same, let's neaten this up a little. 15 times 3x squared would give us 45x squared. X cubed to the 14th would give us x to the 42nd. And when we multiply those together, we'd get 45x to the 44th. So as you can see, we do end up with the same thing when we do chain rule. Here is the formal notation of the chain rule. So if we have some function f of g of x, we would do our derivative rule for the outside function, keeping the inside the same. So for example, when we had 2x to the 4th, something to the 4th was like our outside function, and we kept the 2x the same on the inside. So whatever your outside function is, you do your regular rule for that. And then you multiply by the derivative of the inside function, which in our case, we did the derivative of 2x when we had 2x raised to the 4th. And on the bottom there, that's just another notation for it. You probably won't see that too often. So let's look at some more examples. Say we had y equals sine x squared. Well, sine is your outside function. X squared is the inside. So we'll do derivative of the outside function with our regular derivative rules, keeping the inside function the same, and then we'll multiply by the derivative of the inside function. Derivative of the outside function, sine, would be cos. So we'll have y prime is equal to cos x, or sorry, in this case, cos x squared, because we're going to keep the inside the same. So do derivative of the outside function, keeping the inside the same, and then multiply by the derivative of the inside function. The derivative of x squared would be 2x. Again, we could leave it just like this. If you wanted to neaten it up at all, you could, and write 2x cos x squared. Okay, but you don't have to neaten it up like that. Now, when you have a sine squared x, that is the notation that we write. But what you need to know, and this is especially helpful for when you have to plug it in the calculator, this is really saying the whole thing sine x is being squared. So now our outside is something being squared, and our inside is the sine x. So when we take the derivative, we'll do the outside's regular derivative rule first. When we have something squared, the 2 comes out front. Again, remember you keep the inside function the same, and exponent will go down 1. Okay, so you do regular rule for whatever the outside function is. When doing that, keep the inside function the same, and now we'll multiply by the derivative of the inside function. Derivative of sine x is just cos x. Again, if you wanted to neaten up at all, you could just write it as 2 sine x cos x. And again, what this method is called, this is called the chain rule. Do derivative of the outside function while keeping the inside the same, multiply by derivative of the inside function. So we'll try this one now. Our outside function is something being raised to the 100th. Our inside function is the x cubed minus 1. So we'll start out, we'll do derivative of the outside function. So the 100 will come out front, leaving the inside the same, and it's now raised to the 99th. So we did our regular derivative rule for the outside function, something raised to the power of 100. Now we'll do times derivative of the inside. Well, derivative of the inside is just 3x squared, because the negative 1's derivative is 0. And again, if all they want is the derivative, I'd say just leave it like that. If you wanted to neaten it up, you could write 300x squared times our quantity x cubed minus 1 raised to the 99th. But I would say just leave it like that. It'll make your life easier. Okay, now we'll go back to the examples that we saw before, that we needed a chain rule. Our outside will be something raised to the 7th, just a regular power rule. And our inside will be the 2x squared plus 5x to the 4th. So we'll get that y prime is equal to, we'll do our outside function derivative first. So just a 7 comes out front. Keep the inside the same, now raised to the 6th. And then we'll multiply by derivative of the inside. Well, derivative of 2x squared will just be 4x. Derivative of 5x to the 4th will be plus 20x to the 3rd. And I would say just leave it right like that. Now the second one, it'll be helpful to rewrite it as x squared plus 1 raised to the 1/2. Something being raised to the 1/2 is our outside, and our inside is the x squared plus 1. So when we take our derivative, f prime of x, we'll do the derivative rule for our outside function first. So the 1/2 will come out front. We'll have x squared plus 1 staying the same and raised now to the negative 1/2 because our exponent goes down 1. And then we'll multiply by derivative of the inside, which in this case will just be 2x. And again, you could neaten it up if you wanted. Okay, this would actually neaten up to 2x times 1/2 would just give you x. And then this would be a square root in the denominator because of the negative 1/2. But I would suggest just leave it as your original derivative there if that's all that they're looking for. All right, let's take a look at another one. This will be helpful to rewrite as x squared plus x plus 1, all raised to the negative 1/3. So our outside function is the negative 1/3, and the x squared plus x plus 1 is our inside. So now our derivative, f prime of x, will have the negative 1/3 come out front. Keep the x squared plus x plus 1 the same. When we take 1 away from a negative 1/3, we'll get negative 4/3. Times now the derivative of the inside. Well, derivative of our inside will be 2x plus 1, because the derivative of the 1 at the end is just 0. So now we're going to look at a chain rule that will involve quotient rule. The raised to the ninth is your outside. The t minus 2 over 2t plus 1 is your inside. So our derivative, g prime of t, we'll do our outside, our regular power rule. So we'll have 9 times t minus 2 over 2t plus 1, keeping the inside the same, now raised to the 8th. And now we've got to do a derivative of the inside, which we'll have to do low d high minus high d low all over low low. So low will be 2t plus 1. D high will just be 1 minus high, t minus 2, d low, which is just 2. This will all be over, low, low. So again, we brought our 9 out front, kept the inside the same and raised it to the 8th, regular power rule. And then we did low d high minus high d low all over low low. And I would say leave it exactly like this. Okay, this new example, notice we have two things being multiplied. That means it'll require product rule. So product rule, you do derivative of one times regular of the other, plus the reverse. Regular of the one you took the derivative of times the derivative that you haven't taken yet. So we'll do y prime equals, let's do derivative of the first. So derivative of the first will just be 2x. That means we'll do regular of the second. So cubed root of x squared plus 2. Plus, because it's product rule, regular of the first, x squared plus 1. Now we got to do the derivative of the second. Keep in mind, this can be thought of as x squared plus 2 raised to the 1/3. We've got a function inside of a function, so when we do derivative of the second part, it's going to be chain rule. That's our outside. That's our inside. So we'll have times 1/3, keep the inside the same. 1/3 minus 1 will give you negative 2/3. We still have to multiply by derivative of the inside to finish our chain rule, which in this case will be 2x. So we did product rule that happened to involve the chain rule in it. So we did derivative of the first times regular of the second plus regular of the first. And then with derivative of the second, we had to do chain rule because we had a function inside of another function. And again, I would say just leave it exactly like this. So here's a similar case. We've got a product rule. And notice there's some functions within functions, so we'll have to do chain rule when we're doing it. So we'll start out, we'll do derivative of the first. So we'll bring the 3 out front, because that's our outside in this case. This will be our inside. When we get to the other one and have to do the derivative, the raised to the 4th is the outside. This is our inside. So we'll have 3, keep the t to the 4th minus 1 the same, now raised to the 2nd. Times the derivative of the inside, which would be 4t cubed. So all we've done so far is the derivative of the first. We now need to multiply by regular of the second, which is t cubed plus 1 all to the 4th. So we've done derivative of the first times regular of the second. We'll now do times regular of the second. And now times the derivative of the second. So we did derivative first, regular second, plus regular first, now derivative of the second. We'll have to do a chain rule. The 4 comes out front, keep the t cubed plus 1 the same, raised to the 3rd. Times the derivative of the inside, which is 3t squared. So the black there is the derivative of the first. The red is the regular of the second. The green is the regular of the first. The blue is the derivative of the second. And that's our product rule involving chain rule at the same time. Here we'll have another chain rule example that involves quotient rule. Our outside function is the raised to the third. Our inside is our fraction. So we'll have 3 out front, keeping the inside the same. Now raised to the second. Times derivative of our inside, which is going to be a quotient rule. We'll do low d high minus high d low all over low low. And again, I would leave that just as is. That's all for today's video. We'll see you next class period.